In question number 4, it says a particle is moving along a curve whose equation is given by xy cubed divided by 1 plus y squared equals 8 over 5. And it says x coordinate is increasing at a rate of 6 units per second. So when we talk about x, okay, so this 6 units per second reflects dx by dt. So it's moving to the right at 6 units per second, and at when the particle is at 1, 2. And we can just check to see that 1, 2 actually is the right coordinates. If I plug in 1 and 2, I get 8 in the numerator and 5 in the denominator. So it says, at what rate is the y coordinate of the point changing at that instant? Okay, so what we're looking for here then is we're looking for dy by dt. Okay, so we have our equation that connects x and y already. And so what we're going to do is we're going to differentiate this and generate our dx by dt and dy by dt. Now, as the equation is given, we're going to need to use product rule and chain rule for the related rates, but also quotient rule. But since this is an implicit function, we can rearrange this any way we want. So I'm just going to rearrange this so that it looks like this. I'm going to cross multiply this. And it looks like this expression, when I cross multiply this, would be much easier to work with because I just have product rule, and then I don't have to worry about the quotient rule as well. So this is the expression I'm going to use to differentiate to generate my dx by dt and my dy by dt. So differentiating this, I'm going to get 5. And then differentiating the x, I get dx by dt. I don't differentiate the y. And I'm just going to put that in brackets. Plus x, differentiate the cube. So we get 3y cubed, sorry, 3y squares. And then I'm going to add on to that dy by dt, and that's what I'm looking for. Okay, I'm going to put that into brackets here to make sure I don't lose that. That times 5. And here I'm going to differentiate 1 becomes 0 plus differentiating the square. And again, once I differentiate the square, I can go to the inside and generate my dy by dt. Okay, so then I can just rearrange this, plug in my dx by dt, plug in my x and y coordinates, and then solve for dy by dt. So I'm going to do that first. So I'm going to just replace all the known parts. So this is going to be 6 units per second. The y is equal to 2. X is equal to 1. Y is equal to 2. And then there's my dy by dt that I want to solve for. And I end up with 8 times 2 times y, which is 2, and then times dy by dt. Okay, so then I can simplify this expression. So it becomes 5 times 48 plus, this is going to become 12 dy by dt. And this is equal to 4 times 8 is 32 dy by dt. Okay, then expanding this all out, we end up with 5 times 48, that's 240, plus 60 dy by dt is equal to 32 dy by dt. And then solving for dy by dt, I'm going to subtract 60 from both sides. So negative 28 dy by dt. So dy by dt works out to be 240 divided by negative 28. So negative 240 over 28. And that would be units per second, which simplifies So I can divide by, it looks like a factor of 4. So I end up with negative 60 over 7 units per second. Okay, and the reason why we know that this is falling is because it is negative 60 y units per second, or negative 60 over 7 y units per second.